Welcome back. Here we go. I stole these fatty acids from the front of the exam because I saw two of them here, oleic acid, and linolenic acid. Linolenic. Careful with spelling. There's three of them that start lino. Linolenic acid. And we're going to connect those to two of the three carbons of glycerol. I'll leave the top one for the phosphate. You know there's going to be phosphorus because it says there's a phosphatidyl something. All of them start with the word phosphatidyl, all the phospholipids. So remember, you draw a carbonyl for your fatty acid, and then find your fatty acid. We'll do linolenic here in the middle. There's the carbonyl, 7 CH2s, then a CCC. 7 CH2s. 1, 2, 3, 4, 5, 6, 7. Then a CCC. Comes down to a CH2. Then a CH2. A CCC that comes down to a CH2. How many of those? 3. Trying to get this thing to work here. Purple. All right, so you finish the parentheses. You're down to here. And linolenic, one of those healthy omega-3s, has just one more CH3. Omega-3, because omega is the end, omega-1, omega-2, omega-3. And oleic, 7, then the double bond, then 7 more, and then an 8th. That should be pretty fast. 1, 2, 3, 4, 5, 6, 7. And then a double bond. Then 7 more. Make sure, 7. 1, 2, 3, 4, 5, 6, 7. And then the 8th. I don't know. We used green already. Oh, whatever. Make sure they have even. Hey, quick check, making sure they have an even number of carbons might catch a mistake before it's too late. Remember, they have to have even numbers of carbons because they all come from acetyl-CoA, the acetyl having 2 carbons. 2, 4, 6, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Check. 1, 2, 4, 6, 8, 9, 10, 12, 14, 16, 18. Check. Now, how do you draw a phosphate ester? Well, you got to draw a phosphate. We better know what a phosphate is. I don't let you graduate my class unless you know that a phosphate has 5 bonds. 1 double bond to O. If there's any O's left over, they're usually anions. And then we have to attach something to the right. And you don't know this yet, but inositol is 1, 2, 3, 4, 5, 6. Cyclohexane. Seems complicated, doesn't it? Hexol. It's just cyclohexane with an alcohol on every single position. That's it. One of the positions was used to make an ester with our phosphate. And it says the phosphate ester is equatorial. And how can we do that? Well, we got to do a chair. Remember chairs? A quick chair rundown. Chairs. There's one chair. Here's the other chair. They're not pretty, but they'll get the job done. So I'm going to redraw that red bond. Now, if it's equatorial to this, that's going to be up. Equatorial to this would also be up. Okay, let's just use this picture here. In fact, you want to quite literally use that picture there? Maybe I can't. I drew them both at the same time. It thinks they're the same. Haste. All right, so let's draw a little below the O there. Slightly better chair. Equatorial on this position, slightly up. And equatorial as well on 2, 4, and 6. So here's 2. Here's 4. And here's 6. Remember, parallel to this bond and this bond is equatorial. And there's a bond from the O to the carbon there. And other alcohols are axial. So let's put them on. It's not the prettiest, but it's there. And that's it. Molecules like this are involved in taste, believe it or not. Taste sensations. And what else? Anything else? That's it. So now you've got it. It could be 4 things here. Phosphatidylserine, 4 possibilities for this question. This question will show up on your test. Fact. Now phosphatidylinositol is a possibility. Inositol, serine, choline. Choline's with CH, sorry. Ethanolamine. If none of that makes sense, please re-watch the video with the title, with phospholipids in the title from last day, Monday. You'll have one of them on the test next Monday, promise. And what does hydroxide do? And aqueous hydroxide is going to do saponification of all of the esters. It's going to be, everything's going to be in its conjugate base format except for the alcohols. This hydroxide is not going to deprotonate those. So no matter what the question, be ready to draw glycerol in this box. That's a given for a point every time. Please judiciously use your circles. You want to go everything after the carbonyl? You could have the carbonyl in the circle if you want. I'll call that one R. And it's going to be tricky here. So you're going to have R attached to carbonyl, attached to O minus. That's a soap, as is this one, O minus, carbonyl, R prime. Those are all soaps. I believe that's asked about down here. On a lot of tests it is. Describe the function of these molecules. And this would be a humectant. Whoa, I don't know what I did. Went all the way to the last page after I added a new page, apparently. What are we on, 2 or 3? There we go. Humectant here. Keeps moisture in. That's a good one. I think that's all we're doing on that page. Page 3 is going to be fun. It's a lot of fun. There's a lot of ways to tackle these problems. I'm pretty sure yours is going to be a 12-pointer. But it's not going to be much easier than this one. So here's our 14 amino acids. They're listed alphabetically here. That has no bearing on the order they are in the sequence. 2 isoleucines, arginine, methionine, lysine. These are important. Phenylalanines, tryptophan, tyrosine. The more of those you have, the happier you are. Edmund says Val is first. So why don't we put our, see if we can get everything done by here. So that's where we went first. Okay, what does cyanogen bromide mean? Well, look for met. There's got to be a met, or else there would be no cut. And there's a met, find it. Met is after everything in the sequence that still has met, because everything to the right of met got clipped off, and that makes this the C terminal. No surprise, there's no val in there. So that's the information we have right now. Chymotrypsin tells us that, let's see, I need new color. Chymotrypsin is good for the aromatic rings. It clips everything after them, which means tyrosine was at the end of this sequence. Tryptophan, this is just coincidence. It's already at the end because alphabetically it's at the end. But it is at the end of that sequence. Phenylalanine comes after Sear and Val. Oh, bingo. I'm going to put a 2 on it. I guess this was a 2. We discovered the C terminal here. This is a 3. I know the first 3 amino acids because I know Val is first and I know Ph is third. Put Sear in the middle there. Wasn't that nice? And how do I know this has to be the C terminal? This is the real C terminal. So of all of these guys that were C terminal before, these 4 are the real C terminal. Do you see phenylalanine in there, or tyrosine, or tryptophan? I do not either. That means they were after all of those groups. They were in the last segment. And we'll call this the 2 prime, I guess. A little more information on 2. I don't know. I'm just trying to have symbols to help you follow my logic. Really, I'm only going to grade the final answer. Trypsin. Oh, you know what? Trypsin? I'm going to call that 2 double prime. Glue all by itself. What trypsin does is it finds the lysines and the arginines and clips everything after those. And here we go. That means lysines at the end of this sequence and arginines at the end of this sequence. And I know glue is after everything because it's not with a lys or an arg, so it must have been after all the lyses and arges. And look, it's in here, right? Maybe we can work with that, the fact that these are the last 4 and glue's the last one, and lys is after both isoleucines. Yeah, that's it. Lys is after both isoleucines, and definitely glue's at the end. So what do you got? You know, I got my 2 double prime plus 4. Call that 4. It says lys is at the end of those 4 in 2 double prime, and it's after the 2 isoleucines, which must be connected to each other, huh? Here's the last 4. Glue's the last one of those 4. Lys has to be at the end of these, which is after the 2 isoleucines. We're doing good. Circling some good things here. We've got half credit already, don't we? Yeah, exactly. Half credit. 7 out of 14. Just if you wrote this down, you're done. 7 out of 14. You want more than that, though. All right. Here's our old friend Val. Val is first. Sulfur. My goodness, I think I just got another point. Arg has to be after. And Lou's not down here yet, so I got another 2 points. Got 5. Hot pink. Arg is 5th in that sequence. And that only leaves us with Lou. Lou's the only one in these 5 that isn't down here already. And 5 here and 4 there. We're at 9 out of 15. I'm pretty happy with myself. What other information we got? Done anything with this? Glytier. Glytier and lyse is after glytier. Lyse is, well, it's definitely ice is after glytier. But can we finish off this chunk here? We got 4 of these pieces. We got the 2 isoleucines, the lysine, and well, that's it. The lysine has to be after everything here. What about the tier? Tier was done where? Tier fits. Tier's after gly. Gly tier. And lyse is after all that. So here's when I take a break and I figure out what I've done so far. Just check off things from the list. And hopefully I can count better today. Val's done. Sear's done. Fuzz done. Lou's done. Arge is done. Where are you, Arge? Right over there. Both isoleucines are done. Lyse is done. Certainly we can do something with the met. Yeah, I think that's where I'm going next. But finish up what I'm doing. Glue gone. What about met? Met is with the Val. My goodness, I could have put the met right here, right now, right? Look, 1, 2, 3, 4, 5, 6, and I've got the other 5 already over here. Met goes there. I don't know what color make it. I'll go black. Check. What are we down to? Terptier and glingly. Terptier is here. It's after met. And what do we got here? Let's see. Met. Arge met. This whole thing is before this thing. This thing's over here. Glue's way over there. Anyway, I'm just talking. Have we done this whole fragment here? I see the Arge and the met. Let's go there next. I see the Arge and the met, and I know terps after those. I got the Lou, the Arge and the met. The Lou, the Arge and the met. Oh, this is good. Glun trip next. I'm going to call that 8. I use green. I used 1 green. I can use 8 green too. It's not green. Okay, we've accounted for all of these except for Lou and terp has to be at the end of these. That means this is Lou terp. I think we might be at a point where we just sneak in what's left. Lou terp. We already checked off Lou. Lou's, whoa. Okay. I didn't notice we already had Lou in there. There's Lou. Well, let's take it. I know we can do some more. What color we got? We got red, green. Do we have all 5 of these? 1, 2, 3, 4, 5. We have terp, met, arg. We don't have glyn. So glyn goes here. Glyn. Glyn trip. Trip, glyn. Now the only question is it gly tier or tier gly? Gly tier. Gly tier. Tiers after gly. Look, tiers after gly. And this was our 8 here. And our 9. And there's no reason to say this had to be the order we did our reasoning either. 9 is gly tier. Puzzle solving 101. And that was a beauty. I think that one we got a break after that. Didn't take as much room as I thought. Hey, don't do that. Can move everything up. No, it's all part of the thing. Got a blank space. We can live with it. Okay, I think we got everything there. Hopefully it matches the answer key. Let me just check that before we go. Don't want any disappointed people. Sadly, we can only rotate one direction here, and I did eventually rotate that thing. There we go. And we're going to question, I can't even remember. There it is. That's not the answer key anyway. There's the key. And the answer's there. Nice. I'll snip it. Gly, isoleucine, tier, gly, terp, glyn, met, arg, loof, sir, val. All right, we take a break. Then we come back, and when we come back, we'll be looking at this lovely one here. We'll do both parts, very similar to what one we did the other day. I think it's good to start with one at a high pH to see how that changes the ball game. And then we'll do another one that starts at a lower pH. And I'll see you very soon.